We have v as a function of t, and it's going to mean that a is also a function of t. This is a variable acceleration question. We're given this velocity time graph and the function. This is going to be k. P obtains its maximum velocity at time t. That's going to be here. Given that the distance traveled by P between times t equals 1 and t equals capital T is 297, determine the time when P is instantaneously at rest. So that is, we want to find this bit here. I'm going to assume that the time 1 is going to be after it meets the peak. Okay, but I think it will work itself out if that wasn't the correct. But we've got two unknowns here, so I can't just go straight into integrating. I need to try and work out capital T, and that can be done by recognizing that it's when it's at maximum height. So two methods: we can either differentiate or complete the square to work out the place where it's at its maximum height. So the dv by dt, let's first of all differentiate, is going to be minus 6t plus 24 equals 0 when t is equal to 4. Therefore, I can get rid of that and make that 4. Okay, that was quite quick. I hope that makes sense. I'm just finding the stationary point. I'm also finding where the acceleration is momentarily 0. Or like I said, I wouldn't advise this method, but we could complete the square, in which case you have to factorize out the minus 3. It's going to be t squared minus 8t here plus k t minus 4 squared minus 16 plus k, and then it's going to be plus k plus 48. So again, this will always, this bit here will always be negative, but or 0, and it will take its this function will take its maximum value when, sorry, I forgot the squared, when this thing is equal to 0. And so I've just actually found the maximum, not that it really matters, but this is going to be k plus 48. But basically it's going to be when t is 4. Okay, that is when you're going to get 0 here. So it's just an alternative method. I would definitely go with that one, but it's nice to see that you can do it without calculus. So actually we've got everything we need now. We can just find this area using integration. So it's going to be the integral from 1 to 4 of minus 3t squared plus 24t plus k. If we can work out k, then we're sorted. And we're told that that is equal to 297. Now this is one of those questions where you can't just stick it directly in your calculator. So I'm going to do it by hand, but I'm going to show you how you could take a shortcut. Minus t cubed, increase the power by 1, divide by it, plus 12t squared, same here, divide by the 2, plus kt. Okay, and then substitute in. So 192 minus 64, might as well figure out that bit. Gives 128 plus 4k minus, I'm just going to take it easy here, so it's going to be 11 plus k So 128 minus 11 plus 4k minus k is equal to 297. That's 117 plus 3k equals 297. 3k is 180, so k is equal to 60. You'd kind of expect it to be a reasonably nice number in this sort of question. So therefore, v equals minus 3t squared plus 24t plus 60. And all I have to do now is set it equal to 0. So what was it? Was it p? P is at rest. When v equals 0. So I just need to solve minus 3t squared plus 24t plus 60 equals 0. So 10 or minus 2. Okay, neat question. Slightly different. Oh yeah, I said, didn't I? I said there was a little trick we could use here. And I want to talk about it. So when you're doing this integral, it looks like you can't just stick that directly in your calculator because there's a k there that we don't know what it is. But you could rewrite it because when you integrate, you can just integrate and you're adding terms, you can just integrate them separately. So you could actually write it as two integrals added together. Now this bit you can do, it's going to be kt evaluated. We're going to get 3k just like we did before. And this is where it's quite useful because we can just use the integration function. Sorry, I forgot about the 3. And we'll get 117. So if you can realize that, it's just quite a lot less effort, really. 3k is then going to be 180. And k is going to be 60. I've not actually needed to integrate it myself. And this is accepted in mechanics. And it's more about applying maths and so forth. So we're not expected to show detailed reasoning on how we integrated. That will be expected in pure. But yeah, just an alternative route, which you might want to think about.